So my name's Harley Laue. I'm from Billups Technologies in Portland, Oregon. And this talk is about interface-driven HTTP responses, which I'll get to in a minute because, first off, all of you have probably written this at some point in your career if you've ever worked with HTTP. So it should not look like anything new. So the question I have is, can we do better? And the answer is obviously no. That was my talk, thank you. No, I'm just kidding. So what if the HTTP responses looked something more like this, where we have an interface that we can implement and potentially types that implement that interface? So what this will end up doing is going through each response writer and pushing in the response writer to each of these responsors and doing something with the result, and then eventually writing out the response. So, okay, this will look really familiar to a lot of you if you've read this article or watched the talk by Dave Cheney, which is amazing, and I recommend it to literally everyone in this room and anyone watching. So if you've done that before, this shouldn't be too surprising, but I haven't seen many people doing this with HTTP responses. Usually it's for setting something up, for setting options, but what else is this but setting options to modify the response? So we could do something like this and write headers to the response, so that way you just pass the headers to this response writer, and it takes care of it for you. Or you can set a status code. I know these are kind of trivial examples, but there's some kind of interesting things you can do a little later on. Like if you have a specific content type that you're setting all the time, or a specific thing that you're setting all the time, like a header content type, this little helper here can help you. So here's where it gets to be a little bit more interesting, is being able to do something like, I want to set the content type, and I want a custom marshaller to that. So what you do is you set up something like this, where it looks for the content type, and because it's also a responser, it can call out to itself and pass in the response writer to it and set the content type. And then later on, it checks in this function if that marshaller is set, calls the marshaller, and it does this kind of weird thing with doing *v to an interface, which I'll get to that in a minute because it's going to look weird to a lot of you, and it should for a reason. But it's setting the value of the interface to something different, in this case, a string. So what ends up happening is when it gets back to that previous write, it's just writing that value. So one of the things that sometimes happens, let's say you have to support sending multiple accept headers, and you have JSON and XML because someone out there is still using XML. No offense to anyone. So what this can do is it will check you basically pass your request into here, and it takes types of things to accept and how to marshal those. So what happens is it will check the accept header, do a couple easy checks here to see if it matches any of them, and if it's just has one, it will go ahead and give the first one back because it doesn't care what type to get, or it ranges over those and does something interesting, like when it finds one, it goes ahead and passes that on through. So if it doesn't find one, I have it set up here to automatically return an error with a 415, and it will pass that back as a responser. And because these are still responsers, the chain just kind of knows how to handle that and will write that one out instead. So here's an example of, again, doing XML and JSON because why not? So we have this struct that's GopherCon with an ID and a name. And one of the things that we're doing with it is in this mixed handler where we're taking multiple accept types is we're grabbing we're going to call the responser, pass in the struct, because in this case it's too hard to say grab it from the database or data store or whatever. So I'm just hard coding it in there, and then I'm calling that response acceptable, which was right back here with multiple types. In this case, the JSON accept up at the top and the XML accept. And if that error is out for any reason, it will log the error and be on its way. So what happens is that error type that I had in there, I didn't really mention this, also implements the error interface, so it actually returns like an error, which causes the rest of the chain to just fall out. So you can do things like that. So as a demo really quick, I have this up and running, and if I were to say, call this mixed type, I'm not setting any headers, if you're familiar with Postman, and I get JSON back. Let's say I'm actually going to call this one with a specific accept header, like accept application JSON. So if I call that one, I get JSON back, calling the exact same handler up here. So I also did something interesting on this demo where I decided to also return GeoJSON. So I have this other one in here, vendor GeoJSON, and it just matched that one, all calling the same route. So I thought that was kind of cool. We do something kind of like that in production currently, but our implementation is a little different. And so the question some of you may be asking is it worth it to do this? What I've found is it provides a very consistent API to have all of our handlers implement. That way we're not doing a lot of this and a lot of that, maybe setting the content type, maybe not. It helped us kind of settle on a more consistent manner of writing them. And you can still have wrapper functions where if all you do care about is doing write JSON, you can still have a write JSON function that wraps the write and writes only JSON. So there's not a whole lot of downsides that we've found to having this. And that weird interface that was a pointer, the reason we do that is because you can actually do transforms within your pipeline of those function arguments. So there are a few downsides to this particular implementation, one of which order matters. So if you had transforms that were modifying the value and writing it out to a string, if you anticipated on doing something like implementing a protect method to say remove things that shouldn't happen when they don't have permissions to see that, you've now written that to a string and you've lost the type, so you can no longer do that. And we've done things like that in production where we care about protecting data and we remove it during this chain. We just have to be very careful to always have that one prior to writing out the response or converting it to a string. And the thing I'll note is this particular API I showed isn't exactly what we're using in production. I like it a little better, but it's still quirky because of that. But I wrote it in about an hour for this presentation because I was waiting on an email back from my SVP to see if I could present our code, and he didn't get back to me fast enough, so I just wrote something. So that's the main thing. It's not too crazy, but I haven't seen a whole lot of people doing that with responses, and even if you don't like that method, I highly recommend going back to that Dave Cheney paper and blog post and reading that, because you can use that in a lot of different places that maybe you hadn't thought about previously. Thank you.